Hello students, welcome back to the 8th video of this playlist. So in this video we will be solving question number 8 from P1 May 2024 paper. So let's see what's the question number 8 is about. So if I give a brief explanation about its what's the concepts behind question number 8, it's basically from P1 chapter number 4, there is graphs and transformations. Not transformations, but you need the concepts from the first part of chapter number 4, that is graphs and finding the points of intersections, these stuffs. So in order to be able to solve this question, definitely you should have done questions from chapter number 4, and also some algebraic concepts will be required in this solution. So let's get started with question number 8. Okay, here they say the curve C has equation. Okay, the curve C has equation y equals to x times 4 minus x squared. So part A asks to sketch the graph of C1 showing the coordinates of any points of intersection with the coordinate axis. Okay, so we need to sketch the graph of C1. Okay, so what type of equation is the curve C1? Definitely it's cubic, because if you multiply x with negative x squared, you will get what? X cube. That means this is a cubic equation, so we need to sketch a curve of a cubic equation, right? So for part A, y equals to what? Y equals to 4x minus x cube, right? 4x minus x cube. So for sketching a curve, what are the important things, or what are the important factors you need to consider? At first, the shape of the curve. Since it is cubic, we know that the shape of the curve depends on the coefficient of the x cube. If the coefficient of x cube is negative, then it will be a decreasing curve, and if the coefficient of x cube is positive, then it will be an increasing curve. So here the coefficient of x cube is negative, so that means this is a decreasing curve. So we got the first factor. Second factor is that we need to consider the points of intersection with the what? X-axis. So at x-axis, what would be? Y would be 0, right? If y is 0, then we can write x times 4 minus x equals to what? 0. So either x equals to 0, or you can have a double root, right? Repeated root, that is x equals to, not repeated, wait, this is x squared equals to 4, so you'll get x equals to plus minus what? 2. It's not repeated, it's a single root, plus minus 2. Okay, so it's a decreasing curve. We got the x intercepts and now the y intercepts, so put x equals to 0, you are getting y equals to 0. That means origin would be the y intercept. So let's go for the sketch. So for sketching, okay, for sketching the curve C, the first factor is what? It will be decreasing curve. So since it's a decreasing curve, so the curve C has to start from the what? This quadrant. Okay, so from this quadrant it will intersect the negative x coordinate at first. So this is negative 2, so it will intersect negative 2 at first. It will intersect negative 2 at first. It will intersect okay, let me write it clearly. It will go through the origin x equals to plus minus 2, so it would be equal. So that's how it goes like. Okay, so here since it's a sketch, it shouldn't be accurate, but the shape should be perfect. So negative 2 0, that's what I tried to keep. So it would be the origin 0 0, and that would be what? 2 0. So this is the what? Sketch for the curve x times 4 minus x squared. That's it. This is all about part A. For part B, the curve C2 has equation y equals to a over x. This is a reciprocal equation where a is a constant. Okay, for part B, show that the x coordinates of the points of intersection of C1 and C2 satisfy the equation x to the power 4 negative 4x squared plus a equals to what? 0. We need to show that. Okay, so same like in this paper, it is very frequently, like it is very frequent question, like points of intersection. This is very frequent. At the points of intersection, the y values are what? Equal, right? So what we can say? We can equate them, isn't it? We can equate. How we can equate it? For part B, a over x, this y value, this is the y value for the reciprocal curve, a over x, it is equals to what? 4x minus x cube, the equation of the cubic curve. 4x minus what? X cube. So multiply both sides by x, so you will get a equals to 4x squared, 4x squared negative what? 4x squared negative x to the power 4, negative x to the power 4. So take all of the terms to the same side. So what you will get? You will get x to the power 4 negative 4x squared plus a equals to what? 0. That's what the question wanted, isn't it? X to the power 4 negative 4x squared plus a equals to what? 0. Done. Okay, now part C. Hence, they said hence. That means we need to use our workings from the previous question, that is part B. Okay, find the range of possible values of a for which C1 and the curve C2 meets at 4 distinct points. We need to find out the range of possible values for a such that the curve C1 and C2 will meet at 4 distinct points. That's a good question. So the equation that we have derived just in part B, this is basically the equation for the points of intersection between the what? Two curves, right? So if this equation has no real root, that means there would be no points of intersection. If this equation has one real root, that means there will be one point of intersection between the curve C1 and C2. That means in order to have 4 points of intersection between the curve C1 and C2, this equation should have how many points of intersection? Sorry, how many solutions? 4 real solutions. That is 4 real roots. Okay, so for 4 real roots, we can do one thing here. We can represent this equation in form of quadratic expression. Why I am considering quadratic expression here? The fact is that this is a quartic equation. You can see quartic equation means an equation with power of the variable 4. So we know that for quadratic equation we can use the discriminant in order to find the number of solutions, right? So we will try to do that. Like we will use the discriminant to find the number of solutions for a quartic equation by converting this quartic equation in the form of what? Quadratic equation. Okay, so let's do that. For part C, what we will be doing is that we will write x squared whole square. Can we write like this? Definitely we can, right? X squared whole squared, and then what's that? Negative 4x squared. So you can write negative 4x squared, negative 4x squared, and then plus a. Yeah, this is plus a. So this is plus a equals to what? 0. Now consider the discriminant. B squared minus 4ac. This is what? B squared minus 4ac should be what? It should be greater than 0. Why? This is a quadratic equation with the variable, like in place of the variable it is what? X squared. Okay, it is what? X squared. That means if this quadratic equation has 2 real roots, then within this variable this is what? X squared. Then for x squared you will have 4 real roots. Make sense? So consider b square minus 4ac. So b square is what? 16. 16 minus 4 times a is what? 1. And the a, I meant a as the coefficient of x squared. This is what? 1 times a. So that means a, that should be greater than 0. So what should be the range of possible values for a? 4a should be, take 4a to the right side, you will have what? It should be less than, since this side is less than, so 16. So you will have the range of possible values for a, that is a less than what? 16. So that means if the value of a is what? Is less than 16, less than 4. If it is less than 4, then what we can do? Then there will be 4 points of intersection between the two curves, that is C1 and C2, right? Okay, so we got the value for a, that is what? Less than 4. It should be less than 4, but there's a fact. Look, there's a fact. What's the fact is? The fact is that if the value of a is 0, okay, there's something to be considered. A less than 4. A less than 4, it means what? A can be negative, a can be 0, a can be 3, 1, 2, anything. But if the value of a is what? 0, then there will be no reciprocal equation existing, right? This will become 0, y equals to 0. This equation will disappear. It will not have any, it would not be any equation, right? So that means the value for a can never be what? 0. It cannot be 0, because if it is 0, then you would not have any reciprocal equation in the form a over x, right? Yeah, so the value of a can never be 0. So we got a point that the value of a is what? Not equals to 0. Fine. Now another problem arises. What's the another problem? Look, if you consider the value of a is negative, okay, because a less than 4, that means it can be negative, it can be 0, right? So a less than 4, that means it can be what? Negative, it can be 0. So we already considered that a cannot be 0, because if it is 0, then there will be no reciprocal equation existing. Now what if a is negative? If a is negative, consider if a is negative, then how would be the sketch of the reciprocal curve would be? If a is what? Negative. If a is negative, then the reciprocal sketch would be like this. I'm just showing for your understanding. It would be basically, it would be like this, okay? It would be going like this, isn't it? Remember the sketching reciprocal curves, it will be like this. So how many points of intersection you can see? 1, 2, right? That means the value of a can never be negative in order to have 4 distinct points of intersection between the curve C1 and the curve C2. Make sense? That means we need to have a limit for the values of a, right? Isn't it? So what would be the limit in this case? The limit would be the value of a, what? You don't need to write any reason. I just wrote it for your understanding. The value of a should be what? The value of a should be greater than 0, less than 4. This is the range of possible values for what? A. Make sense? So this is all about question number 8 from May 2024 P1 paper. That's it.